Well, our speaker tonight is Thomas Hale. He's well known to many of our members, and he most recently spoke to our club back in January of 2024. Well, Tom hails from the Roanoke, Virginia area. He was first generation college student at Virginia Tech. Go Hokies! And he graduated in 2019 with a BA in political science. He also focused on mineral resources, and he was active in the Virginia Tech Geology Club. And if Betty, if you could pull up the two slides, at least one of the slides that I sent. I guess if you can, if we can zoom in closer, we might actually see Tom's name on this. But this is how I first became familiar with Tom Hale, because I visited the museum, the Geosciences Museum at Virginia Tech, because our daughter was going to school at Tech, not in geology, unfortunately. But I noticed his name on a couple of the displays in the Geoscience Museum. Those were displays about Virginia minerals and the history of mineral resources in Virginia. But what really caught my eye, if you could switch to the second slide, the second slide, it noted that that Tom was a 2019 political science major who had volunteered to put these displays together for the museum. And I always thought it was curious that a political science major was so into minerals and was such a great volunteer for the school there. Well, Tom went on after Tech to complete a Master's of Arts in Security Policy Studies and Conflict Resolution from GW's Elliott School of International Affairs. And he's currently a PhD candidate in Geography and Spatial Sciences at the University of Delaware and doctoral fellow at the United Nations University. His doctoral research, for those of you who may have seen a tie-in back in January of 2024, is geopolitics of critical minerals in South Greenland's Gandar province. In addition, Tom is an avid mineral collector with over 2,000 specimens in his collection, and he runs the nonprofit Virginia Mineral Project, and he founded the Virginia Rock Hounding Group. So please join me in welcoming Tom Hale as he helps us explore Virginia's mineral resources.
All right, thanks, Laura. I much appreciate it, and thanks everyone for having me back. I will apologize because I think I was scheduled for January to come and speak to the group, but I was actually in Denmark then, and I'm sure it's not long to be searching on the web to see that this year has been quite interesting with the U.S. relationship in Greenland, and it's been quite a busy year for me and my work, so I was unable to make it, but I'm glad to be here tonight, and I'm also excited to talk about Virginia minerals and Virginia mineral resources because a lot of my time now is spent up in the Arctic talking about those mineral resources, which are really fascinating and really, really cool. But it's nice to come back home and speak about this subject, which many of you have known me for over the years in the various projects and the evolution of that. But tonight, there's going to be a lot of great images, a lot of different things, and I've included, let's see, some images that folks have yet to see. And a lot of tonight is going to be kind of a quick review. I'm not going to give any specific like deep dive geologies, but really I just want to go through each province in Virginia and highlight some of the different mineral resources, famous locations, and then really open it up for a Q&A and discussion for us to have a conversation. And to John's question about the specimen found in Moorfield, it could be triplite. That was a specimen where you had this red center and then a dark outer coating. So it'd be interesting to ever get that identified if it's at the university. I don't have many pictures from the Moorfield just because it is quite a popular spot, so I thought I'd highlight some more rare and unusual things in tonight's presentation that we don't normally see a lot of images of. So just again, I'm going to give a brief history of mining in Virginia. Of course, this is not a full whole historical overview. I do have presentations on YouTube if you are interested in learning about the kind of the founding fathers of Virginia mineral resources, a lot of the information historically of how a lot of these publications came to be. I'd be happy to send those links and a follow-up to the newsletter if folks are interested in all the different presentations that I have online about specific mineral deposits. Then we'll go into mining in Virginia today, just kind of a quick overview of what it looks like today. We'll go through the mineral resource overview and then spend a lot of our time just breaking it down by the physiographic provinces or the geologic provinces to see how they change as we go from the Appalachian Plateau all the way to the coastal plain. And then I can't say enough about the photography tonight. So Connor Williams is a young photographer who we worked with for our project at Friends of Mineralogy Virginia. And the photographs that you're going to see tonight are by him. He did a phenomenal job about bringing many of these Virginia minerals to life through his photography, because I think for those that have known me all these years, one of the biggest challenges is getting high quality images of many of these rare but also very popular locations, because technology has evolved, photography has evolved, but unfortunately the publications that are out there are mostly outdated in black and white. And of course, our Trap Rock book was kind of the newish publication for the state that had colored images, but really getting good images has been a job that we wanted to do and try to preserve this history. So a lot of what you're going to see tonight is from that photography. On the right side here is a wonderful smoky quartz crystal, something that you would normally see from the North Carolina area, but this was actually found in Chesterfield, Virginia, when a housing complex was being developed back in the 80s. And what's really cool is not only do we have this sample and we have the original labels with it, but we also have a housing development plan and document of the housing complex as it was being developed. So someone got a copy of that. So I have a really cool spot of where they found it, which is unfortunately sitting underneath someone's basement right now. And like many of these locations, I don't think many of the people that live on many of these famous sites are rockhounds like us, which is unfortunate. But it is cool that we can still preserve these things to share those stories generations later. So, from to start with a brief history of mining in Virginia, I guess we can really talk about the utilization of resources by American Indians, looking at flint and other types of things for tools and for hunting. This is really when we kind of look at the first use of resources in human society here in Virginia. It's really interesting. You can go down to central Virginia. I've been in the Charlotte Courthouse area and found specimens of rhyolite that had been quarried in North Carolina and then transferred and traded up into Virginia. But it's also common, like in the Saltville area, where you find incredible quartz crystals, to also find a lot of flint and byproducts from tool manufacturing by early American Indians. Around 1619, you had bog ore mining that became a major development near Jamestown. Of course, it makes sense for civilizations to develop. You have to harness these natural resources. So 1619 is really when you begin to see kind of a documented mineral industry here in Virginia. During the Revolutionary War, there was mining in the Alstonville lead and zinc mine in Wythe County. This is a very important area, not only because of its connection to, let's say, critical minerals as we know of them today, which is minerals useful in politics and strategy, of course, because this was connected to the Revolutionary War and our independence, but also because this is one of the longest operating mine sites. I put that in quotes, in Virginia's history. Why? Because it was operated back in the 1700s and has through history been operated continuously in various different products. I think today most of it is the byproducts of a lime, but still a very important site, operated for a very long time, very important to American history. And today you can see some of the byproducts of this really interesting tower, where they would drop a lot of the pouring kettle for the lead, get it into the bullets, into the lower shaft, and kettle filled water, and then extract that to make and manufacture the bullets. So really cool historical things from our early Revolutionary War when it came to mining in Virginia. Then you had commercial production of coal in the United States from the Richmond coal field. This is a Triassic basin. I think a lot of us are very familiar with the trap rock quarries and the prehnite, but we also had trap rock basins in the Richmond area. Of course, we extend that down into North Carolina with the Solite quarry. If you've ever been to the Virginia Museum of Natural History, you would be familiar with this very popular Lagerstätten deposit, where they find old lake bed sediments, where you have all sorts of incredible fossils. but this was a commercial production in the mid 1700s. The Virginia's Geologic Survey was created in 1835 by the Virginia General Assembly, and the focus here was to characterize and map the extent of Virginia's mineral resources. So this is when you get Thomas Leonard Watson, you get William Rogers. These are some of the first fundamental folks that write and characterize our geology and our mineral resources in Virginia. And then that sits as a bedrock, pun intended, to a lot of the later publications that we see by R.V. Dietrich and others at the Geologic Survey. But really fundamental in the mid 1800s, during wartime and before wartime, to really begin to see these characterizations begin to take place. By the 19th century, gold mining was very prominent here. There was a lot of mining, there's a lot of prospects. Of course, we have the Central Virginia Gold Prospectors Club in our state. But of course, as the gold rush in California began, you saw a lot of that move out west. It's a very big challenge today when we're looking at abandoned mine inventories here in Virginia to look at a lot of mercury challenges and pollution from these early gold prospects. If you're part of the Central Virginia Gold Prospectors Club, on Facebook, you can probably see sometimes the people are posting gold pans with mercury in the stream beds, and so this is a very big issue. And for it being a very, very old thing in the past until it moved out to California, we're even at the point today where in Buckingham County there's a disputed gold mine there that's gotten all the way to the National Academy of Sciences for those living in Nova, due to its environmental potential impacts. So still relevant today, believe it or not, discussing gold and its impacts on the environment. During the Civil War, we saw a lot of salts from Saltville, Virginia, which were, of course, being used for preservation of goods and materials. There was battles fought in that area, and of course, it's a very strategic place. I do have a whole presentation on the Saltville area with its quartz crystals and its geology. You have everything from American Indians sites there. You have the salt mines. You have the incredible fossil beds there. And you also have the beautiful quartz crystals. So a very incredible place geologically. And all of that geology, especially from a political or a kind of a geography perspective, brought all these different civilizations, people, and animals to that place. And so even the non-collectors, just people that were trying to live, animals that were trying to eat and live, were coming to this place because of the geology that happened over millions of years ago. So it's a really incredible place to visit today. Not much there, but it's still a beautiful place. And then by the 19th century, late 19th century, you begin to see construction materials becoming an important sector. I bring this up not because it's necessarily as interesting, but because that's what defines Virginia's mining economy today, is mostly things like sand and gravel, aggregates, and other things, rather than these metallic or mineral resources that we would see in our cell phones and things like that. A very different economy than out west. Here's just a sample of a beautiful gold specimen from the Virginia Gold Pyrite Belt. This is in my friend Andy Dietz's collection, so a lot of the images tonight are going to be in his collection and my collection. And this is a nice specimen, and this is kind of representative of some of the pieces that you would see out west. But of course, we do have stuff like this found in Virginia. The Spotsylvania gold nugget that's on the front page of 1990 Dietrich's book, but also in the Smithsonian. But there is a lot of really interesting things. But again, getting photographs of them and high quality has always been the biggest challenge. Again, by 1907, Thomas Leonard Watson, as I discussed, creates the Mineral Resources of Virginia. So with his book and, of course, William Rogers' book, both of them, by the way, are free and accessible on Google Books. So you can type in Mineral Resources of Virginia by Watson, and you can type in The Geology of the Virginias by William Rogers, and you can find these books and read them. You're not going to find information that's relevant to today. Things have changed, geology has changed, but still, it's really interesting to read these things and to see what it was like for people prospecting at a time before the industry had become large in the early 1900s and mid 1900s. So it's a really interesting perspective for mineral collectors. In 1958, until 1958, you had the Cremora mine, which was the largest producer of manganese in the United States. Of course, this is really important in alloys and steel production, corrosion prevention, and aluminum cans. And so that was one of these sites where today we hear about manganese as being an important resource. You hear a lot about deep sea mining and these polymetallic nodules, which of course have a lot of manganese in them. And Cremora was a very important site. JMU is actually having students out there right now researching some of these old tailings, but the site today is actually filled in, is a nature, not a nature resort, but an actual place where people can go stay, so like a campground in a resort. Barite production was actually really important in Fauquier County from 1845 to the 1950s. We used this with fluids, drilling fluids for oil and gas wells, rat poison in the past, green firework coloring, radiology for x-rays of the digestive system. So a lot of different stuff. So again, Virginia has a lot of interesting resources, but not something that we think about today. You had the major titanium mining from the 1940s to the 1970s. I think this is really important because a lot of people on Virginia Rock Hounding are posting about blue quartz. So I think that's really cool because when we look at Mike Wise's article from the 1980s, he wrote about how blue quartz was related to titanium inclusions within the crystal lattice of the quartz here in Virginia. So there's kind of this connection. A lot of clubs will collect at the old mine. There have been trips to the old American Rutile Quarry in the past, and that entire area produces a lot of blue quartz. So a major industry in the past, but also part of today when it comes to rock hounds finding a lot of blue quartz. So that geology industry connection is there, but is not often made. And then I always tell people that the last hurrah for Virginia was the 1990 mineral publication by R.V. Dietrich. Again, I recommend you check out that presentation because I go through all of his articles. And for those that have read The Minerals of Virginia and his books, I was able to speak to Dietrich before he passed away. And I thought it was fascinating to learn that it wasn't really of interest to him. It was actually, he came from New York. He was a mineral collector. He came to the geology department and people said, oh, you're a mineral collector. Therefore, you should identify all the minerals that people bring in. And he's like, okay, I guess so. And he had a grad student at the time that was really interested in writing books and things, kind of similar to what I was doing. And so that got started, and there was interest from the government, there was interest from the university to produce those publications, and it grew into one of the most important mineral resources that documented collecting, but also the mining history in Virginia. But it's quite interesting to find out that it was more of a push and prod from a student rather than it was an original thought from the university and the government itself. Today, however, the government is not very interested in updating these publications, which is unfortunate. But again, the power of grad students, I'll leave it at that. So today, mining is basically dominated by the construction aggregates production. It's about 80% of our commodity production in Virginia. About 71 million tons of crushed stone and 11 million tons of gravel were produced in 2024, and that's a valued industry of around 1.8 billion. 73 of our 95 counties have aggregate mines. That's probably, well, that is because you can only ship aggregates so far before it becomes economically unfeasible. So you have to have these very local operations that develop these cities and would develop the infrastructure that we want for these roadways. And so when you look at Northern Virginia with the trap rock quarries in the book that we wrote, it was really important that these quarries not only were documented for their importance to the industry, but also the mineral resources that were discovered in many of these aggregate operations that built Washington, D.C. and the surrounding areas. There are roughly 300 aggregate operations today in Virginia. I do have a website that I can share again as a follow-up link that goes to the Virginia Department of Transportation and Construction's database where you can actually look at all the quarries in Virginia. Doesn't mean you're going to get access to them, but you can actually look at them all on a map and see what they're producing. But throughout our entire history in this state, there were 56 total commodities that were mined here in Virginia. So when people come up and say, there's nothing in Virginia, there's no industry in Virginia, maybe not today, but historically, Virginia has hosted many famous mine sites that were essential in the United States' development and innovation in technology. We just don't think about it today, but it has been something that has brought us to this point. Coal, of course, is still very important, and an industry in Virginia, 10 million short tons of bituminous coal in 2024, and no surprise with given energy developments that's been down 4% since 2023. We do have the kyanite mine at Willis Mountain, which of course it has a field trip in September that the Lynchburg Club hosts. They open it up once a year. Last year, there was around 86,000 tons of kyanite, which is around $36 million. And they're two hard rock pits. That's really our primary mineral resource, and it is the largest kyanite producer in the United States. So that is an important mine site for the U.S., and it has actually taken a lot of heat because of the Buckingham gold mine issue a lot of activists have actually tried to shut down the kyanite mine, which has created a big dispute between the various stakeholders, which was something that I was also working with the state on challenges around that, trying to defer the difference between the kyanite mine and this potential gold mine. And then we do have Virginia vermiculite. If any of you are garden people or plant people, of course, vermiculite can be very important for us. And so 61,000 tons in 2024, and a very small industry, but still a lot at $11 million dollars. But you're here tonight to learn about our mineral resources. So let's get into the bread and the butter and really focus on the beautiful specimens that our state has. Again, with the collection that I put together at Virginia Tech, when I got there as a student, the biggest challenge was that the university had all of those specimens in mineral flats in the base or in the basement or underneath the cabinets. None of them were put on display. There was really no interest and putting those out there. And so what I told them was, why don't we do this? Break it down by the geologic provinces, the physiographic provinces for educational standards so that we can teach when the schools come and really highlight these mineral resources because an alumni had spent a lot of his time and his money collecting these things at Tucson over the years. And as we all know, Virginia minerals are hard to come by. It would be important to showcase these. So this presentation really goes through the same process of highlighting province by physiographic province by province to show you the different resources that can be found and hopes to also highlight to you what things you can expect to find in these areas that you can't find in the other provinces. Um, I was actually shocked. I don't know if any of you follow MnDAT's Virginia page regularly, but when I first made this presentation a couple years ago, there was 430 mineral species documented. I looked on MnDAT the other day for a class I was making, and now there's 454. So a lot of this is probably just updating resources because a lot of MnDAT's information about Virginia has to come through the community sourcing. A lot of this stuff comes from the old Minerals of Virginia books, but I've still been trying to figure out what are the new species that have been added to MnDAT over the last, 3 years, which has added, quite a number. If any of you know, I'd be glad to figure that out so we can see what the new ones that have been added. But there's 450 total in our state. We have three type locality minerals: Goose Creekite, Loudonite. Probably know where those are coming from, the Goose Creek area and the Loudonite, or Loudon area, and Rockbridgeite from Rockbridge County. Our state rock is Nelsonite. I think to the ire of many mineral collectors, we wanted it to be Unakite, but it is Nelsonite from Nelson County. And again, every province provides unique mineral resources. And the way that I try to teach this and with collectors and for my rock hunting class is that you want to know where you're going so you know what you can expect to find, because otherwise you may get disappointed or what you're looking for may not be there. So always keep that in mind. We have several regions that I think are worth your time looking up online and looking up articles. We have the Virginia Pyrite Gold Belt. I think Packard's stamps shop in Richmond area actually have produced a really cool long map of this. So if you ever go by Packard's rocks and stamps, he actually has a map of the Virginia Gold Pyrite Belt where you can see all the different prospects. Something to think about. The Austinville Lead Zinc District, again, very historical, but wasn't a major specimen producer. However, there was a lot of really nice material at Virginia Tech University. So if that is of interest to you, go by their university and check out. They have a lot of Austinville lead zinc stuff. Really beautiful fluorescent sphalerite there. We also have the Amelia pegmatites, the Rutherford mine, the Moorfield mine, all these pegmatites that were really important for collectors and produced a lot of what made people interested in geology by going on school field trips to visit these mine sites. I think we underestimate, or the current geologists of this state underestimate the power of mineral specimens and how it intrigues people to get into this field. We have the Valley and Ridge carbonates and quartz. You get a lot of calcite crystal collecting sites in the various quarries like the Belmont Quarry. You also have quartz crystals found in this area like Chestnut Ridge. And then you start getting into the coastal plain where you move away from the minerals and you start getting into the fossils, getting into much younger sediment, and of course heavy sands, which is really of a potential mining interest today. And I think we are moving forward on some new heavy sands mines here in the state. So that is something to look forward to in the coming years. And then Virginia Line of Copper Belt, which extends down into North Carolina, where you get some interesting mines that have malachite and azurite and other interesting minerals there. But again, most of our state's history around mining has been lost in time. And I think part of that is just because we don't have really new innovative ways of teaching it, showing these minerals, and really connecting students to things that they're used to, which is technology, which is all these different updated, colorful images. It becomes a really important tool to get people and capture their attention in today's world. So here we have a kind of cross section of Virginia. Gives you a good look of our various primary physiographic provinces. So we have five, if you include all of them. We have the Appalachian Plateaus, which we start from the left here, getting near West Virginia. We get into our Valley and Ridge, our Blue Ridge, our Piedmont, and our coastal plain as we get out to the Chesapeake Bay. We also have these Mesozoic basins, which again are coming from the separation of the last supercontinent Pangaea. That is important for the coal mining in the Richmond area, but is also very important for creating the thinner crust, which allows these igneous intrusions to come up through the rocks and produce a lot of these diabase dikes, which is where we're really important and putting these fluids and these geologies that created the trap rock quarries that we collect at, and many people have collected over the historical kind of collecting history in Virginia. There is a map at the bottom right. I wish I had a better map of this at a higher resolution. I don't. I think it's important here to note, someone remind me at the end of this presentation, and I can talk about this further, but when Virginia Department of Mines, Minerals, and Energy changed their name in the last 5 years to Virginia Energy, all of the links on Google were broken. You may have been used to in the past searching things like Blue Quartz Virginia on Google and being directed to a PDF file, which would give you information like the old Virginia Minerals publications. All of those links are pretty much broken, and I see that many of them have been removed from Google search. So you actually have to go to the website of Virginia Energy, go to their geology program, and have to click on the maps and publications database to actually access many of these resources. So it is a little bit more trickier now, but as a club, it's important to let folks know that because it's not just right out there. And I think it's a tragedy because it makes it very hard for people to find this because those links are broken. But a lot of these resources you can find on their database, as well as an interactive map where you can type in your address to find these things. So let's start. We're moving from the Appalachian Plateau, so Western Appalachian Plateau, and moving through eastward to the Chesapeake Bay. So we start out here with flatline sedimentary rocks. These are mostly carboniferous in age. This is where we think a lot about the coal resources in Virginia as a main industry. Coal, oil, and gas, of course, minor aggregates were the important resources produced here. But the coal mines are really the focus when we think about the geology and the kind of collecting that happens in the Appalachian Plateau. My friend and I have been here many times, and we have actually seen that there are places where people's homes are built on top of these old mine tailings, and we could spend 30 minutes and fill up a car full of fern fossils, old stigmaria, which were the roots to these fern-like or tree-like ferns. You can find a lot of stuff around everywhere in the Appalachian Plateau because they threw that stuff out, and many of the fossils are out there lying around waiting to be collected. So there's a lot of that, but very little minerals to be found. However, Wise County did have some minerals that were discovered: celestine, strontianite, and calcite, very similar to the Holston River quarry, which we'll talk about here soon. And these specimens were limited. I think that Richard Mitchell or Dick Mitchell had actually had some samples from here, but I think it was near a military base, so a lot of that access has been limited. You may see this come up and referred to as celestine geodes in the old Virginia mineral publications, but really these are just small, as I'll show, vugs of celestine rather than they are actual geodes. But again, very limited geology, mostly focused on the calcite crystals, some quartz, strontianite, and celestine. Locations, again, the Wise County quarries, the coal dumps, and Tazewell and Russell counties. I recommend if you can get down there to go out and explore, because you'd be surprised at how many areas and small towns have so many fossil beds that have been just left over and put out there waiting to be discovered. It gives you an example here of what I'm talking about: the calcite, the strontianite, which is in the middle, and the celestine on the right here. And then on the bottom here, these are the stigmarias on the two left sides here, where you can actually see these kind of large roots to these tree-like ferns. What I think is really cool if you're a collector here is that you actually see the xylem and the phloem, these internal structures in the roots, which transports the nutrients in the water, still preserved. So I actually have pieces that broke in half, and you can actually see, I think, the xylem still preserved, which I think is really fascinating. And also here, unlike most of the places where you just find the stigmaria down here on the lower left, you can also find appendages that would stick out from these little nodes, which were the kind of smaller roots that would collect the water. So I think it's really cool that you have a lot of soft preservation here of a lot of different things that you don't see in many of the carboniferous fossils that you find in the Valley and Ridge. So then let's move to the Valley and Ridge. I think for most of us, we define the Valley and Ridge as far as proper, beautiful mineral specimens from the Barger-Corys pyrites, which is the one on the right here. This sample was collected by Buck Keller, and this is also a sample that is the one that we used for our logo for Friends of Mineralogy Virginia. It's the exact one that was drawn by the artist, and we have a lot of cool artists and posters of this sample if you're interested in those. And I really think this defines probably the most important and famous samples and specimens from the Valley and Ridge region. The geology of this region is defined by long parallel ridges and valleys underlain by ancient folded and faulted sedimentary rocks. We see this as we're going through the Shenandoah Valley, going down and up Interstate 81. A lot of the folding and faulting here, the sedimentary rocks occurred between Africa and North America during these collision processes, so very old. And these oldest rocks here around the Cambrian in age, around 520 million years old. And then the youngest rocks you get here are Carboniferous, around 300 million years old. The Carboniferous rocks you find here are at a different set part of the Carboniferous than the rocks that you will find down in the Appalachian Plateau. So I think it's really interesting if you're wanting to have fern fossils from two different periods in the Carboniferous. Go to the Valley and Ridge and go to the Appalachian Plateau, and you'll get a different diversity and to see how things are similar or may have changed during these periods. As far as mineralogy goes, here we have more diversity than we do in the Appalachian Plateau. You had the very famous iron mines that were very important during the Civil War. So these iron-rich sandstones that were used. This is where we find a lot of the slag glass in Virginia that people go out into the rivers and they collect. That's where a lot of the mistakes about obsidian come from. There is no obsidian in Virginia. There's no obsidian east of the Mississippi. But these iron mines produced a lot of really cool slag glass that people still collect and find today. We have a lot of aggregate operations starting out here in the Valley and Ridge. A lot of those are coming from carbonate deposits. Of course, for the Hokie stone at Virginia Tech is a dolostone down there that they have their own quarry. And then you do get quartz crystals that erode out of some of the limestones in this area. So you'll see a lot of reports from Virginia in the Valley and Ridge where you have these Saltville quartz diamonds or Saltville diamonds or Ellet Valley diamonds, where local communities and farmers, as they were tilling their crops and preparing for the season, they would find these quartz crystals that would erode from the bedrock, come up to the surface, and they would collect them. I think it's important to let everyone know that even though you can still find quartz crystals in these areas today looking for weathered deposits, it is very difficult because farming practice, agricultural practices have changed. So a lot of the areas where minerals were found in the past, like amethyst, even in the Piedmont, those places don't till the ground like they used to. And so you don't necessarily get a lot of material coming to the surface, finding a lot of these crystals. So it's a lot more difficult to collect today, not just because of private property, but because of the way that agriculture has evolved in our state's history, which I think is a really interesting relationship to highlight. But again, you do have some metal deposits with lead and zinc. You're getting into that kind of area, getting into the Blue Ridge, you're going into these different places. But most of what we're talking about here in the Valley and Ridge is focused on the iron mines or iron sulfides. You get a lot of different things like the quartz crystals and the limestone and the calcite crystals. The Augusta County area near James Madison University and the Stanton area produced wonderfully large calcite crystals from the Belmont Quarry, a very popular site for collectors. There's a very large specimen that was donated by the quarry owner, I think in the 70s, to the Virginia Department of Energy that you can go see at their museum in Charlottesville. But other than that, many of the specimens have been out in collections. There is some at Virginia Tech that I put on display, but not a very commonly found mineral specimen to find in collections today. What is more popular to find is the Barger pyrites. Clubs still go there and collect today. The Lynchburg Club and the Roanoke Club have regained access to the Barger quarries. There have been some samples coming out, but not as prolific as they have in the past. Again, remember, as you're mining and quarrying, the geology changes, just like the trap rock quarries. You may not be getting into the zones where the pyrite was more prolific. So these things have a time limit on them, not just from the legalities of it, but just from the geologies that limit us and how these specimens come out. But some things are being found today, which I think is really cool to see new Barger's pyrites. But for a lot of the Valley and Ridge, the iridescent hematite, as Kenny was talking about from the Peters Mountain area and these old iron mines like the Jordan's mines, you do find iridescent hematite. We really don't know fully the origins of the iridescence, of why it looks like that. But what we need to create this is space. So just like you see cave stalactites from Luray Caverns, we have a very iron-rich sandstone. Cracks have to form. In the case of the Peters Mountain, it was a localized thrust fault, opened up space. The hematite was able to precipitate out just like stalactites do in the Luray Caverns. And then something happened that changed the chemistry or allowed for this iridescence to occur. There are multiple phases of iridescence. So I think that's really interesting that you can actually see layers underneath the layers where you had iridescence. And unlike all the iridescent locations from the United States and across the world, like in Graves Mountain, Georgia, this is the only location where you have barite that was actually formed. And you can find these barite pseudomorphs on the stalactites sometimes, but I actually do have samples of barite crystals still preserved in the pseudomorphs that look like, call them tic tacs. But that's something that I think deserves more studies and further studies. I knew Virginia Tech had done some work, but it had not been accepted. And I also know that Caltech produced a paper, but that paper was rejected. So there's a lot of interesting uh, studies left to do on this iridescence. And then the strontianite and calcite quarries in Pulaski and Dublin, you can still get there. A lot of the samples that we collected when I was younger at Virginia Tech were actually in my own backyard. So we knew that the rocks were coming from this quarry. We knew the quarry had produced crystals. And these rocks are really known for their kind of flat bedding planes. The geology allowed for these nice big flat rocks. And so they were putting them in a stream bed behind our house. We went out there and we were able to collect calcite crystals and strontianite just outside our back door. So that's a pretty cool spot for a mineral collector. But you had to know the geology and you had to know that those rocks were local. And then the Bath County had the Chestnut Ridge, which was discovered by hunters in the 60s. And when they were hunting, they found these quartz crystals. And for many years, clubs have went up there and collected beautiful small quartz crystals reminiscent of the material down from Arkansas, but very small, nothing on a large scale. I think the largest crystals are normally 3 inches, but those are very rare. Most of them are still around an inch. Here's the specimens of the strontianite. This has a lot of oxidation on it. Because it is a carbonate, there's really not much you can actually do to remove the oxidation. I think it looks pretty cool. You get a lot of pockets that do have no oxidation, so it looks really, really white puffballs. And then you get these calcite crystals on the right here, which are big chunky crystals. Normally you get smaller rhombohedrals, but a lot of mineralization here at this quarry, but not necessarily a diversity of minerals, but just really nice quality minerals that can be collected. Inside these chunky calcites are very small needles, which we think are potentially pyrite or some other iron mineral, but there's been no classification or studies to identify these, and that was one of the big efforts we were trying to do at Virginia Tech, was to get the university to take on this for a student, but we didn't get any buy-in or support from it. But there is still a lot of information of some of these unidentified minerals from the quarry that need to be accounted for because they are currently not listed on MnDAT. This is just a good up-close image. Small field of view here, but you can actually see the strontianite and the calcite crystals, and again, that oxidation that gives you kind of a good look at what the calcite crystals normally look like from the site. But a very, very beautiful location, very nice place to collect. On the left here is the iridescent hematite. Again, very phenomenal coloration. Most of the collecting here was done in a very small cave. It was discovered in 1970 when they were building a fire trail in Allegheny County, and then they opened up during the fire trail, they opened up a very small cave. I put that in quotes because it's really not a cave. It was just a crack from a thrust fault. They collected samples in the 1970s. Lance Kearns and others came out to the site. Um, but this site has been filled, unfortunately, with horse foam by the state survey. I don't know why they did it. After many years of collecting and people going to the site, the state government came in and filled it up with foam, which is very unusual because it isn't a fire trail and there was really no major collecting happening here. But there are still a lot of specimens out on the market, so a very popular site to go collect at. You can find iridescent hematite at Willis Mountain, so that's probably the best likelihood of you finding something from Virginia today is to go on a Willis Mountain field trip. In the middle, here's a beautiful quartz crystal that we collected down in Saltville, a very unusual morphology, very chunky. We collected this before a rainstorm. I took a chunk of clay out, went to Subway and was parsing through it and found this beautiful crystal here in the middle. Again, it's only about 4.1 centimeters, but still just a weird type of quartz to find. But that's what Saltville was known for, these really interesting crystals. You also have ramshorn gypsum, which is very uncommon to see from Virginia, but this is from the Rockbridge area. Very beautiful specimen here. Something like you'd see in Mexico and other countries, but a really interesting Virginia specimen of the ramshorn formation. Another good look at the Barger's Quarry Pyrites. You want to get an N matrix, which has that nice black blue color grading, but you can find a lot of Barger Quarry Pyrite crystals as singles broken off from the matrix. I actually had found these crystals, a very large amount of material, in an old bronze bucket that was in an old antique shop, and I looked at this case, and it was a dark, dim, dusty case, and I looked in the back, and I saw these rocks, and I knew the morphology. I was like, that's so unique. That has to be Barger's Quarry, pyrites. And I was able to get about 80 specimens. One of these is what you see here of these Barger's pyrites. And this is a pretty decent size at 3.7 centimeters. On the right here, we have another sample, looks much like Kinney's, which is this nice kind of purple pink coloration that you see on the iridescent hematite, which isn't as normal to see as it is this kind of typical Roy G. Biv coloration here. This kind of pinker and other colors are very, very uncommon. The golder colors are not as common as you would see the other colorations. I also had this sample here, which I think is really interesting. So this was given to me at the Shenandoah Valley Gem Show about 3 years ago. And this was from a lady who had walked her property and found a stream bed that was intersecting an interesting geology that apparently had quartz crystals. So this is related to the Valiant Ridge, where you get these quartz crystals just like the Chestnut Ridge. But this is an unknown, unidentified spot. It is coming from the Shenandoah area. I have enough background information to verify this, but this is not documented. This is not has not been reported, but it is something that warrants further investigation. I have not had the time to get out there to do it, but this is a really cool discovery that happened within the last 5 years, and I don't think we see a lot of that, but there are still things being found today. And if it wasn't for Virginia Rock Counting for the website, you wouldn't be able to get these people to find a resource to come out and talk to. So we're very proud that we have that ability for people. If you do look closely, you can actually see some very small phantoms inside the quartz crystals. Again, this piece is only about 7.2 centimeters across, so decent size. But again, a really cool piece. Looks similar to the Arkansas quartz crystals, but is our kind of small scale version of that. And when you have the right conditions, you will see stuff like this form and some of the sandstones in the Valley and Ridge area. Now let's move on to the Blue Ridge. This is where we have a high ridge separating the Piedmont from the Valley and Ridge province. Again, a very popular, very famous mountain range that we hear a lot about in tourism. This is a billion-year-old igneous and metamorphic rock, so it's the oldest rocks in our state, about 1.1 billion years. Structurally, the province is a large eroded anticline overturned to the west. The mountains are made of highly deformed metamorphic rocks. Most of these are Precambrian ages, so very, very old. And here you get a lot of intense tectonic deformation, so you find a lot of interesting metamorphic minerals and metamorphic features here. So there's a lot of great locations for surface collecting. I think that the Blue Ridge is one of the places where a lot of people find stuff today. You get these metabasalts, you get the blue quartz, you get the jaspers, you get a lot of really cool. That's where the Nelsonite came from. Get a lot of interesting things here. So the Mount Rogers and Buffalo Mountain, Mount Rogers named after William Rogers, our first state geologist, if you didn't know that. And Buffalo Mountain are really cool places to go on field trips, tell you a lot about the geology a very long time ago. The Fairy Stone State Park with the starlight crystals, the Nelsonite from Nelson County, these limonite after pyrite crystals in the Schuler area. This is in Albemarle County. You can find them. They call them Jack's dice or devil's, I mean, Jack's rocks or devil's dice locally, but a very popular thing to go out and find if soil is accessible. When I was younger, my friend and I were trying to find places to find these limonite or these limonite cubes, and we found a bed and breakfast that was known for having pigs, and you could live with the pigs and you could have the pigs in your bedroom, and it was part of the Airbnb that you could just hang out with pigs. Well, pigs love to go out and rummage around and lay in the dirt, so we actually went out to the pig sties and actually looked for limonite cubes and picked up a gallon bag full. You have to be a mineral collector to do something like that. But again, when you have soil exposed in this area, it is worth looking for these crystals as they weather out. But very localized to the Schuler area or Schuyler area where the Waltons was taped, the TV show. And the American Rutile Quarry, which of course is the blue quartz, and the Rutile, Vesuvius with the Unakite, and then the crystallized turquoise from the Bishop Mine area. Blue quartz up here at the top left, the starlight crystals, the Nelsonite on the top right. I call it a salt and pepper rock. Not as pretty as the Unakite down in the lower left, where you have these beautiful pink potassium feldspars, green epidotes, and some smoky quartz in there, and biotite. So a very beautiful sample, which was the unofficial state rock, but unfortunately, this is our state rock, Nelsonite. Unfortunately, Nelsonite was only found in very localized igneous dikes, these kind of vein-like features. So there's maybe like 4 or 5 of them, a very limited amount. So it's not like you can find the Nelsonite. You will walk the creek beds and find things that look like Nelsonite, which is a very old granite, but it is not Nelsonite. You're looking at ilmenite, which is the black, and then an apatite, which is the white. Eventually, as it's exposed, the apatite will weather away, and you're left with a very yucky looking kind of iron, slaggy looking rock. You also have slate mines in this area, or slate quarries. Believe it or not, they still hand break the slate today. So I took a group of teachers out to this quarry about 3 years ago, and they actually got to see people with their pickaxes and hammers chipping away slate shingles. Even in 2023, by hand, it is still a place where you have to do it by hand. So I think it's a very unique place to go visit because you can see very old mining practices at play. And then on the lower right here is what we call migmatite. We have so much heat and pressure as these mountains are being developed. This is the early tectonic orogeny, so the Appalachian Mountains are being formed. You have tons of heat and pressure similar to what you would see in the inside of Mount Everest. And there's so much metamorphism occurring here that it almost turns into an igneous rock, and you get this kind of concentration of quartz veins that look like intestines or like a heartbeat that forms out of that intense metamorphic activity. So very incredible specimens here. This was collected by the Geology Club because it is a protected nature preserve, but a wonderful place to go visit, go hike, a very short hike, a little bit of a difficult hike, but lots of incredible geology, a lot of microfolds and things that you can't see at a very large scale, but just a wonderful place to go visit and spend an entire day. And then, of course, the crystallized turquoise, the famous Lynch Station crystallized turquoise from the Bishop Mine. I think it's funny, I don't know if those are familiar with this site, but when they came and discovered this, they looked at the blue and they thought, great, we're going to be really rich with copper. So a lot of the original samples from 1910 were smelted and melted. And then in 1911, they realized that wasn't going to be good and wasn't a great ore, so they just went bankrupt. So unfortunately, this site is also unavailable to collect, but there are specimens out there. And for a very long time, this was the only place in the world that turquoise had crystallized. So a very popular site. There are some other smaller locations, but this is still the premier site of crystallized turquoise in the world, is around the Bishop Mine area. But here we are in the Piedmont, and this is really the bread and butter for collectors. This is where a lot of the famous mines have been. This is where a lot of the deposits where people think about collecting have been located. And this is a site where many famous places have been found and discovered, and where a lot of our collections focus on. That doesn't mean that we don't have things from these other quarries, but the Piedmont has produced a wide variety of mineralogically diverse species. This is an area that we talk about with rolling hills. It's underlain by very ancient igneous and metamorphic rocks. These igneous rocks, of course, are the roots of volcanoes, so the internal structures that have weathered away. because remember, the Appalachian Mountains used to be as big as the Himalayas. All of that sediment that has weathered away is now what creates the coastal plain. That's why it's young sediment. But this is the insides of that mountain. It is the roots, it is the structures internally that have been eroded away, which is really cool that even though we feel like as mineral collectors we lose access to these places, imagine taking millions and billions of years to get to the right conditions where you can find these deposits and then having a very small period of 10 years where you can collect them. On the geologic timescale, you are very lucky to be able to hold these samples and to find them and to be able to experience these internal geologies, because otherwise, go back millions and millions of years ago, you wouldn't have been able to find it. Now, sure, there would have been other deposits that have all weathered away now, but it is something to think about how incredible that can be. The Piedmont is well known for its complex mineralogy. As I said, the Amelia County pegmatites are very popular, and you got a lot of hydrothermal quartz veins that were around these areas, and that produces a lot of the amethyst and other sites where people have collected. Here you have the Amelia pegmatite district, the Virginia Lina copper district, the Pyrite belt and gold belt. You have the Bedford pegmatites, the amethyst deposits, and you also have the Coles Hill uranium deposit, which is probably a very complex and very politically driven topic on uranium mining in Virginia, but it is located in the Piedmont. But there are so many more. The sample that you see on the bottom right here is a garnet that I personally collected in Bedford, Virginia, about 6 years ago. It is a remarkable garnet, almandine garnet, and it is just a beautiful sample from these Bedford pegmatites that were focused for mining due to their feldspar. A lot of these mines in this area, it's important to note, of course, were not mined for their mineral content. They were mined for things like mica, or mined for things like feldspar. And then these byproducts, these other weird oddities, are what we collect today in the tailings. On the left here is a good sample from the Halifax County Copper Virginia Lina District, a really interesting malachite specimen. It looks like, I don't know, one of those I'm forgetting the name of the game now that we all played during COVID. It was the hiding game, or like who murdered who, these little creatures, but a really interesting green sample there. We also have an unusual chalcedony on quartz from the Scufflin Acres mine there in Farmville, Virginia. And then this is a really interesting prospect out in Fredericksburg, Virginia by Buck Keller, I think in the 80s, where you had these very phenomenal quartz crystals. The surface of them are not very clear. They've got a cloudiness to them, as you can see, but very large samples, very nice samples that came out from a very small road cut that only had a one-time collecting at. So really interesting samples, very rare to see. We also have beautiful amethyst all across the Piedmont. This is one from Prince Edward County, from Virginia, and you can see here it's only about 2.2 centimeters, but a beautiful, beautiful amethyst from the state. We also have a very popular chunk of the Moorfield Mine Amazonite, which I think a lot of us are fond memories over. So very important mineral species for our state. Many people have thought about making it our state mineral. Of course, it's Colorado's. But I think maybe. But Amazonite is a very popular stone that a lot of people remember from school or school field trips, and it holds a lot of weight in the collecting community and just the general public today. A lot of people know about Amazonite in Virginia from the field trips at the Moorfield mine. We also have samples of the mica. So I know that Kenny was also showing his zinwaldite. We have a beautiful hand sample of the zinwaldite here, where you actually get the nice book formations there, where you can actually see the morphology of the zinwaldite. And then you also have an interesting muscovite from a very small prospect in Amelia called Jacobs Creek. And this is where someone had went and collected these really interesting weathered mica books, or muscovite books. This is a hand sample size, but a lot of them were smaller, but a very interesting prospect because this had a river running through it. So these were found on the side of a riverbank with a lot of soil, and it was being dug, and a lot of them had been weathered or worn down by the water and floods. And so just to think how many years, if you had never found that spot, that we would not have had these samples to look at. We also have a columbite crystal from the Mitchell mine in Bedford County, a small piece, but very cool. If you are on Virginia Rock County right now, you may be familiar with a gentleman named David Kingery. He's been doing a lot of prospecting in Virginia, posting photography. He's one of my good friends, and he has been finding a lot of really cool stuff in these Bedford area pegmatites using radiometric, or kind of radiation monitoring techniques to look at and look for these heavy mineral deposits. And so really interesting to see that in play as a collecting and prospecting technique. On the right here, it's not a great sample, but it is a cool sample of the microlites, which are very famous from the Rutherford mine right here. And then you can see a nice little book of the mica here. This is probably a fluorocalcio microlite. There's a lot of different names for the different chemistries, but the fluorocalcio microlites were the most common and most prevalent microlites from the Moorfield mine. We also have the Rice Farm, which produced a lot of amethyst over the years in Virginia, where people would go collect beautiful samples here, where you get nice clear crystals looking very reminiscent of the Jackson Crossroads down in Georgia. We had our own material here. And then we also have this really cool kind of double terminated amethyst crystals here, which has really interesting hematite needles. I don't know if you can notice it right in this area, but you see all sorts of needling within here as a trace impurity there, which is really, really cool. But incredible specimens that came out of the Rice Farm. This is one of my favorites because I think it's probably my favorite specimen is the one on the left. It's a molybdenite crystal from the Dale Quarry in Chesterfield, Virginia. It has been noted to find, there have been noted molybdenite specimens from the Dale Quarry for many, many years, but this sample is just so perfect. It is perched perfectly on top of this feldspar matrix, and it looks flawless. It looks beautiful. And I got this for a nice dollar amount of $15. So you can't get better than that. It was self-collected by someone at the Richmond Club, and I'm just very glad to own it and very glad to add it to the collection, especially for my critical minerals collection, because it is a beautiful sample from Virginia and a very unusual species to see at that quality. We also have the very famous Scufflin Acres amethyst, known for being a very dark, smoky coloration, kind of a smoky amethyst is what people called it. Unfortunately, the tectonics at this site were active as the amethysts were forming, so a lot of the faces have kind of a dusting of quartz on top of them. So they're not very pretty, but they're interesting. And what you're noticing here looks very similar to what we call the Cumberland habit in quartz. So these very beautiful Cumberland habit amethysts that were very special for the mine at the Scufflin Acres. This is a cool image of tourmaline and muscovite. You can see this at the Real mine in North Carolina, but this is really cool from the Rutherford mine. So really cool photograph of that tourmaline kind of going through the muscovite books. And then we also have a specimen from the Trueheart mine, which was a small prospect in Amelia County as well, where you had these very small aquamarine beryl crystals. And what's cool about this is that you get to actually see that in the matrix. A lot of the beryl crystals are always out of the matrix. So I really like this piece. There is a large sample. I think it's in Packard's Rock Shop if you wanted to go by and visit, where there's a very long, maybe 6-inch aquamarine. And there's a famous photograph out there of the aquamarine as it was discovered that day with a nice quarter for reference from the 1970s or something. Oops, sorry. This is cool too. Early on in Scufflin Acres, you may not have seen this if you had been there collecting yourself. Early on near the riverbed or the little stream that was down at the hillside there were these crystals where you had kind of a clear smoky crystal, more of a clear quartz crystal, with these really interesting amethyst phantoms inside of them. You can actually see these little globes of hematite or goethite in here, but beautiful amethyst phantoms that were not very common in the later collecting that happened at Scufflin Acres. So this is very early material that we're seeing here. And then you also see these little etched little faces here. It was very common to see things maybe like calcite rhombohedrals or something that weathered away and left their impressions on top of the surface of the crystals. But a very cool piece to look at from an unusual find at the Scufflin Acres site. I think we talked to Sarah about Tiffany Company back in the early 1900s. Charlotte Courthouse had found an amethyst site. This is where Tiffany Company hand dug for amethyst a very, very long time ago. This is a large sample on the left here, but a lot of the pieces were very common on the right. So these are small amethysts, faceted grade in some cases. And years later, people would go and collect them in some of these small trenches. Unfortunately, there's a lot of tree growth there today, which makes it difficult, but you can still go see the trenches from the original Tiffany mines. And the Courthouse Historical Society is very, very interested in these sites as well. But very beautiful amethyst found here. A lot of the smaller ones that you see down there looks similar to what John Betts has. Is a really cool location. But again, it's hard to think about that a jewelry company would be hand mining for amethyst right here in our state, and look where Tiffany is today. A huge, huge, very popular company mining all over the world, but to know that some of their original mines were right here in our own Commonwealth. And then this is a really interesting smoky quartz find from the Goochland area. It was a soccer field, a lot of limited collecting. Is one of those places where the Richmond Club had gotten access for a limited time, but very incredible crystals here. Very, very lustrous, very pretty faces, and big samples. This is a pretty large sample. And you also have the mineral fuchsite, so a mica there, fuchsite. The green that you can see here was also at this site, but a very small period of collecting and then no more. So it's one of those things where you get a limited access and then it goes away. I do have two weird, wacky photos in the Piedmont section on here. This is a really cool piece showcasing the active geology of the Scufflin Acres site. So what we see here is a brecciated amethyst plate. We can see that there had been a lot of activity, which is grinding up the crystals, breaking them down, and that this was actually angled almost similarly to the position that you see in this image. So it's facing up, the dust is coming down, the chunks are aggregating in the bottom due to gravity, and this very thin film looks like sand coating on top of the crystals had fallen over it as the tectonics were active, and then all of that gets solidified and preserved, and then millions of years later we find this sample. So a very cool piece that showcases the geology. You got to love geology in order to love this piece, but it really showcases the activity of the Scufflin Acre site as it was being formed and why many of the samples are not a high quality. And then on the right here, this is just something kind of silly, but this is a root that had a rough quartz crystal from the Rutherford mine stuck in it, which is in Andy's collection. Someone, I think, collected it back in the 80s. So it's kind of cool that someone kept this because you may throw it away, but it's just cool to see this quartz crystal that got stuck up in the roots, to see that kind of geological history with the natural history, with the nature and the biology interacting. I think it's cool whenever we find these minerals crystals stuck in these old root structures. And then lastly, the Dale Quarry, which is where we had the green giant that was found in 2019. So this is a very large beryl crystal. It was one giant boulder, produced about 20 some specimens. And you can see the green giant down here at the bottom. Not a high quality pieces, but still very, very cool and a very recent and unusual find from our state. So again, we're still finding things, contrary to a lot of people's belief that many of these places are closed down. And then lastly, before we get to the Mesozoic basins, it's the coastal plain. I won't spend much time here because we're mineral collectors, just to say that once you get past the fall line, which is where the Piedmont meets the coastal plain, mostly young sediment, all this is weathering from the Appalachian Mountains, getting deposited out to the coast. A lot of the things that are left over have to be weather resistant, so you get a lot of beautiful quartz sand beaches. And there's very few mineral things to be discovered here. What has been found here on top of the fossils, the Jeffersonius chexpecten and the shark's teeth, is these really interesting gypsum crystals. These are noted to be in the Alexandria area, but these are also noted in several places up in Maryland as well. For those that are Maryland collectors, they will probably be familiar with sites in Maryland that also have these gypsum crystals, but we also do have them stretching down into the Northern Virginia, Washington, D.C. area. How you collect them, where they were found, I don't really know, but we do have a lot of history and documentation to support that we also had those gypsum crystals on the other side of the bay, on the Virginia side. And then if you are familiar with the Ruck's Pit clamshells in Florida, just to note that we also do have a clamshell fossil location found a long time ago, maybe 60s, in the Virginia Beach area, where you had someone digging a pond or a lake or something like that. I think it's a pond. And they found these beautiful calcite clams that were hollowed and had these beautiful dog-tooth calcites growing inside the fossilized clamshell. So we do have that. You can go to some of the state parks in Virginia and find calcified clamshells. They're not going to have crystals like this, but it is still interesting to know that all the way down the coast, not just in Florida, there have been documented locations in the same geologic layer of these calcite clamshells that have these beautiful crystals in them, and they're also here in Virginia. And this one's on display at the Laura Robbins Gallery in Richmond University. And so I'll end the presentation on the Mesozoic basins. I did this because this is where you all are, and I think this is where a lot of you are familiar with collecting these samples of the pyrite, the prehnite, the apophyllite. These are Triassic rift basins. These are basically breaking up from the, of course, Pangea separating, you get these thinning crust and these diabase intrusions, which create these chimney structures, these volcanic chimneys, which have these beautiful line prehnite chimneys with apophyllite crystals growing on top of them. This sample here, or this photograph here, is a very rare image from John Medeci, which many of you may be familiar with reading the documents. I was able to also meet with him and talk with him before he passed away and got a wonderful catalog of photographs from his collecting and images from many of these on site looking at the diabase dikes as they were being extracted. So very cool to be able to see this um, from what it actually looked like as you were collecting, not from the on the tailings, but actually in the actual chimney. So a whole lot of minerals here. Over 85 mineral species are noted in these Mesozoic basins at these trap rock quarries, which is pretty phenomenal. So a lot of really cool stuff. And again, 2 of our 3 type locality minerals were also discovered here, which is the Goose Creekite and the Loudonite. And shout out to the micromineralogists that are with us tonight, our micromineral collectors, because if it wasn't for people who appreciate the small things, many minerals would never be discovered. A lot of minerals are very tiny. A lot of minerals can be very rare in the deposits. So people who sit there and appreciate the small things, I highly recommend going to the club up there in DC and checking that out, because a really cool hobby is to look at very small, interesting mineralogy that you can't see at a macro scale. And so here, you know, well, you can look at our book and you can see all the stuff that we have. But the Sanders Quarry is one that we don't get a lot of photographs from. A lot of people are not as familiar with this site. It was getting more towards going away from the Northern Virginia area. But beautiful calcite crystals here. The stellarite and the chabasite were a very popular collecting location pre-COVID. Kind of in the mid 2000s in the Manassas Quarry. So these beautiful orange stellarites and kind of rhombohedral chabasites. Prehnite from the Bealton Quarry, I always thought was really, really pretty. It was way prettier than some of the other quarries. You get this nice lustrous looking crystals. We also have scolecite. So again, you get zeolite mineral formation here, the stilbites, and the sphalerite on the prehnite, which I think are really pretty to see some of these samples. But again, smaller, but still very special. And then here is kind of a hand size sample. And this is the apophyllite on prehnite. This is your kind of type location vibe for the, or locality vibe for the apophyllite and prehnite. This is what it looked like. And one of the things that we did in our book is that we went through a lot of collection material to try to piece on how the apophyllite changed over all the different years that people collected it. Because every year you would go back, they would change as you're going through the deposit. So we were able to document what the apophyllite and prehnite looked like from the 60s, the 80s, the 90s, and the 2000s. It changed over the years. So we tried to put some sort of temporality to the specimens. So not only could you locate where they came from, but you could kind of get an idea of how old that material was, which I think is really cool. And then on the right here is a beautiful label and another specimen of the apophyllite and prehnite. And then I'll end the slide here with just some other specimens. This is on the back of our book cover, a beautiful stilbite. I realized that I don't have the names here. I apologize for that. But you can see 2 calcites down in the bottom right. Really unusual variety and morphology there, these little calcite balls. And then right here, you get a nice prehnite vein where you can see the calcite growing in it. And so I think that's really cool to actually have a little vein that you can hold in your hand and kind of see how these crystals were forming. If the space was available, you got nice stuff. If the space wasn't available, just like Scufflin Acres, in this case, it looks like a peach jelly sandwich, but for Scufflin Acres, it looks like a peanut butter and jelly sandwich, where you just had the white quartz vein and a big streak of purple amethyst, but no crystals. It just looked like a sandwich in cross section. But anyways, that is our kind of quick rundown tour of Virginia. I know it kind of over time here, but I'd be happy to answer any questions that you have and to talk about any of these sites further. Again, this is not a full comprehensive look. There's a lot more cool locations, but a lot of what you're seeing tonight comes from the photography work from the Virginia Mineral Project and our attempts to also have a Piedmont book, which maybe in the future we'll be able to do. So thank you for your time and happy to take questions.
Wow, thanks. I really appreciated that. That was so cool. That was so awesome. A great presentation, and I can't believe how much work you probably put into making that before we actually get anywhere.
Oh, the Amazonite?
No.
Oh, I can't see it. What is that?
Turquoise.
Oh,
Turquoise.
okay. Now I see. Okay, sorry. It's coming up green on my on my screen.
Yeah, it's a little, well, the lighting in here, but
It's a
yeah,
very nice sample. Yeah, it's
I,
always nice to get it on the quartz.
I couldn't, it's amazing what's in here. It's like, it's a total pegmatite. You
Yeah.
have quartz, you have the mica. It's a great one. I couldn't turn that down.
Tom,
Question.
let me ask you, in your work at the Virginia Tech Museum, would you say that would be about the best place to go to see Austinville minerals?
Yes.
I know you and I have talked about the problem of finding collections of Austinville stuff, but
Yeah, so I think I can't remember his name off the top of my head. I don't know why I'm forgetting it. It's been so long since I've mentioned his name. But the alumni who created that exhibit, Don Dalton is the name. Don Dalton. Some of you may know that name. But anyways, he worked for ExxonMobil, and he I think purchased what must have been an Austinville lead zinc district collection of really nice calcites, look very reminiscent of the Elmwood mine stuff, and the sphalerite and the galena and all your stuff like that, chalcopyrite, dolomite crystals, and they're at the display there. They have a really beautiful specimen of sphalerite about that big.
wow,
Small veining of sphalerite, but nice crystals. The crystals there are really orangey yellow or kind of a yellow green, so they're different. They're not a ruby jack like you see in the MVTs in Tennessee, but pretty stuff. Really, really cool stuff.
yeah, thanks.
Okay, I've got one.
Yeah.
The blue quartz. What is the material in the quartz that makes it blue?
So I'm happy to provide the article from Mike Wise, and I know Mike Wise has been a speaker for your group, of course, with the connection there. But it was blue. It was titanium. Was the kind of understanding there was something with the rutile and the titanium. I know that there had been a discussion between titanium, but also some sort of refraction or something happening at the crystal lattice with a refraction and cleavaging, which caused light as well, light play.
I was told it was like a kyanite mixture,
No,
real
no,
kyanite.
yeah, definitely not the kyanite. No.
It's not kyanite. Okay.
Yeah. I know it's not that, but I think there's two kind of theories. I think it's the light refraction type of play there, and then also the titanium inclusions.
I know Tamori has a question.
Yeah, Tamori.
Yes, I think that the raised hand is not really the best strategy right now. No, I wanted to say when I was living in Virginia for a few years, I did find this like rock that this that looks like obsidian. And I was thinking, wait, is this like glass or something? Is it? And I was thinking, is it obsidian? You know, why is it just here? But now, thank you for
Yeah.
clarifying. You said it's a slag,
It's
most
a slag
possibly.
glass. Yeah. So it's a
Yes.
byproduct from the iron foundries down in the Valley and Ridge. So as they were
That makes
producing,
sense.
yeah, they were
Well,
producing
it's still pretty, and it's a nice artifact.
Yeah, yeah. I mean, I think what's cool about it is there have been people, again, at the Shenandoah show, Bob and Mary McIntyre, some of you may know them. Um, they have actually cabochoned and actually processed some of the slag glass from some of the more prolific slag foundries where it really makes beautiful jewelry. I mean, very beautiful cabochons out of the slag glass when you can get it not to be so kind of bubbly and have air bubbles in it, but really, really nice material. I actually had a gentleman come to the Lynchburg show last month and brought up a sample and he said, I think I found a meteorite. And I said, it's a meteor wrong. I said, the many times that I've been asked, is this gold? Is this a meteorite? I probably could be a millionaire. And I said, well, first off, you got a lot of air bubbles here that you can visibly see from that foundry process. I said, unfortunately, no, I think it's just a nice chunk with a lot of iron in it. But yeah, so it's unfortunately, I hate to break people's hearts about the obsidian stuff. I don't think there's been any documented obsidian that made it across the Mississippi either.
Yeah, I mean, I was doubting it as well. It was like amongst all that feldspar, but I'm still happy to have it. So
Yeah,
Could
yeah,
also be coal.
yeah. It could be.
Coal gets very confused with obsidian.
oh, it does it have that smoothness to it as
It
well?
can.
Oh yeah. Okay, I'll see.
Possible.
Weight will be a determining factor in whether or not it has a streak, right? If you're taking on a ceramic plate and you can actually streak it, I don't think your slag glass, because it's just silica, mostly quartz, will have a streak. So if it streaks, it's probably coal. If it doesn't streak, it's probably going to be your slag glass.
Okay.
Quick note, everybody, we are at 9 o'clock. So we are in bonus time right now, just as an FYI for where we're going. I thank Mr. Hale for his time, but if there are those of you who wish to depart, we will not take it offensively. But well, let's hang for a little bit for a couple more questions because this is riveting. This is awesome. So please.
Thomas, I just want to say what a fabulous presentation that was. I just can't believe that all those minerals you showed, those amazing photos, are from minerals from Virginia. It just really blew me away.
Well, you know, I would elevate again here as I've tried to elevate years past. You know, we did the Northern Virginia Trap Rock book, and we were able to work with Andy Dietz and have a small collection of people. But when we wanted to do the Piedmont book, we got a lot of pushback from collectors that were not interested in working with us because they didn't want their images and their knowledge out there. I would advise anyone who is over the age of 60 to reconsider and think about putting the images out there and getting a photographer that we can pay to do these things, because it is really vital this stuff gets preserved. I know it in our hearts of hearts now. It is our collection. It's our history. But eventually we're not going to be here. And these samples need to be carried on so new generations can appreciate them. So we're very thankful that we have these images. But Ken, there are so many more amazing, incredible things from Virginia that I just wish we could get photographs of. And I hope as I continue in the future, we'll have an opportunity to do it.
And is August Dietz the same as Andy Dietz?
Yes, of course. Yes.
All right. Just wanted to check.
I go by his label, which is August Dietz, his label. Brian, I think you have a question.
Yeah, absolutely extraordinary. I mean, I'm sitting here in DC and imagining this is within driving distance and walking distance, whatever. Extraordinary. Thank you very much. I got a couple of phone calls. Are these photos available in either online or because I wanted to share them with my wife who was busy and my daughter.
So what I can do is I'd be happy to share the presentation as a PDF to the group. The problem is, as you can imagine, it's quite a large PDF because these are quite high-res pictures. So I have to share it via Google Drive link. So you may have issues getting it, but I will give it to whoever. Reach out to me from the club, and I can provide this presentation for you to share. Unfortunately, we don't have anything online at this time.
Okay, well, thank you. Absolutely fabulous. It
appreciate it.
Blew the holiday weekend out of the water.
Thank you.
Thank you, Thomas. That was a great presentation. It's a small world. You know, David Kinergy is the guy I bought the hematite from. Great guy. Met him down at the Richmond sale down there that I went to. And Connor Williams, he's a friend of mine from New Jersey.
Yep.
And Father Greg Williams, very good friend of mine. So just a small world. But,
well, I can tell you this. I can tell you that there are things happening, and I'm hopeful. I'm working with David on. So I think there's some exciting things to announce in the future from Virginia mineral stuff. I think there's a publication-worthy thing that we're thinking about working on of a discovery that I think is really interesting.
Great.
Let me let you know, Judy
Thomas.
Lieberman had a question.
Oh,
Judy Lieberman asked, where did you collect the rock with evidence of the migmatite? You mentioned it was a park.
So it's Buffalo Mountain State Park. It's down near Willis, Virginia, I think. It's not far from Virginia Tech and kind of the Rafferty area. You get off 81 and you go that way. You can actually see North Carolina from the mountain peak, but geologists actually study Buffalo Mountain so that they can understand the internal processes of what's going on in Mount Everest, which I think is really fascinating. So when I was working at the State Department, I actually brought a sample of the migmatite to Tenzing Norgay, who was Norbu Tenzing's son, or maybe I have it backwards, the first Sherpa to hike Mount Everest. And so basically I akin this to a heartbeat of an ancient mountain, which is really what it is. So a lot of geologists come to Buffalo Mountain to study that. So I do recommend, if you're interested in tectonic mountain building processes and looking at the geology of what is actually going in Mount Everest, Buffalo Mountain is a pretty good analogy to some of those processes.
Course, don't know about also that. How does it happen? How does the crystallization process occur?
I'm sorry, I can't hear you. I think you're breaking up.
Crystallization process.
Sarah, just put it in the chat and we'll read it out for you.
I think what's happening is the quartz that's in this deposit, maybe as a nice word, it's kind of segregating out and isolating itself because it's being melted almost. And the rocks around it are being melted. And so it gets in these forms, these kind of, you can look up migmatites online and see all sorts of like interesting intestine looking folds and heartbeat style stuff. There's also just stuff here that's just really, I mean, almost looks like an accordion. I mean, it is folded to where it's jagged. We're not talking wave folds. We're talking just like someone squished a piece of paper. So incredible deformation at the Buffalo Mountain site, because this is in the internal bits of the tectonic orogeny. I think it's maybe 500, no, maybe 425 million. I don't know, somewhere around there old.
And Sarah's whole question was crystallized turquoise. How does that happen?
I don't know why.
Well, she keeps going, so let me tell you
Yeah.
the whole thing. How big have the crystallized pieces occurred?
Yeah.
I'm wondering about facet size.
No. Yeah, so these are very
Micro.
small. Yeah, very, very tiny micro minerals, really. As far as the formation of the crystals, I have no idea why the crystallized turquoise formed here and it didn't crystallize anywhere else. I don't know how I can really explain that as to why. This is a manganese prospect is what they were looking for in the area. I think they found this, they thought copper. There's a lot of manganese prospects in the area. But I mean, it's really one of its kind. I have no idea as to why the crystal formation and the geology allowed for it to mineralize like that. I have no idea. But I mean, we're talking about, as I think Dan showed in his sample there, you have a breccia formed in this deposit too, and you have these cracks, and you're getting this infill in these cracks in these small spaces, and it's just a coating, it's a covering, so it's almost like a druzy, right, rather than it is any sort of large crystal. I actually do have samples that are on the mica schist, and I went in an old collection one time, not to be boasting my collection, but I actually went in this old Craigslist collection, walked into this shop, climbed over all these old boxes and dust and rat whatever, and actually found I have samples of it on the mica schist this big, all encoded on the face of those mica schists, mostly kind of perpendicular to the plane. It's really interesting to see. They're not very pretty as the quartz samples, but they're still crystallized as a druzy.
Thank you.
Yeah. I wish I knew. I wish I knew why the iridescent hematite was I mean, there's a lot, but I think that's the point. There's so much interesting things here in Virginia that deserve so much more research, and I just wish people could see that. Like, there's so many things for students to work on that still has applications for society and technology today, and I just think that it's a tragedy that we don't highlight our own resources, and we often send our students all far into the world rather than letting them explore what's around them and from their own area to learn a little bit about their home place.
I just wanted to mention you mentioned Packard's Rock Shop.
Yeah.
I was on active duty and stationed at Fort Lee, Virginia from 1971 to 1973. And I think I bought 7 or 8 pieces from them, and I still have them. And I display them. Big pieces too. Beautiful. And it's good to see they're still in business. God bless them being able to, make a living out of this.
I mean, Packard's has amassed a local community, and I mean, that's what you got to do at a small business level. But I mean, he's got interesting stuff. He also has a small publication called Virginia Rocks. Has anyone seen this? Or Virginia Dig Virginia? No, Dig Virginia. It's the emblem of Virginia, and then it's a pickaxe. But he has a small publication on collecting locations that he made back in the 80s. But that's stuff that I try to preserve, right? Things that people only made in these limited edition prints that once someone passes away and someone's family throws 3 documents away, that was it. There's nothing else like that. But he has this book. So if you go to a shop, ask him about it because he'll be happy to show you.
Okay.
All right. Anything pressing and urgent? Kenny Reynolds, you're on mute.
Oh, Barges Quarry Pyrite. That's a nice sample.
All right. Yes, it's a little plug for the Southern Maryland Mineral Club show that's coming up on October 4th. I went down there and I was all about the Barger Pyrite because of Thomas's presentation, and I bought 5 of them from Dave Lines. Self-collected, just great pieces. So
I know. I think I need to start getting commission on my Virginia mineral interest sales. No, I'm just kidding. You got to make people excited to buy Virginia minerals again. Create a market.
Yes, sir.
I'm just kidding.
Right on.
I do
Thank
it
you,
because
Thomas.
I love the history of it.
Me too.
Yeah. Well, anyways, if you don't have
Presentation, buddy.
any questions, you're always happy to reach out. I'm always happy to answer any questions that you have. So very, very always glad to do. And thanks
Thank
for
you.
having me.
Thank you,
Thanks for allowing me to
Thomas.
talk about Virginia, not Greenland, for once.
Thank you
Uh,
so much for
funny,
that
most people
amazing
talk about Greenland.
presentation.
Everybody.
Guys.
All right. Thank you,
Bye-bye.
everybody. Have a good
Thomas.
night.
Bye.
Great
Thank you.
presentation, Thomas.
Thank you.
Fabulous.
Bye.
Thank you very much.